Hello everyone, in this video I will talk about sections 1.2, 1.3. 1.2 is called the rectangular coordinate system, which most of you are familiar with this. So remember, this is the x-axis, this is the y-axis, and you have 4 quadrants. This is the first quadrant, this is the second one, this is the third one, this is the fourth quadrant. Okay? In the first quadrant, x and y are positive. This one, x is negative, y is positive. Here both x is positive and y are also positive. Here x is negative and y is also negative. Actually, no, here is a mistake. X is positive and y is negative. Okay, so now this is just to refresh your memory, because most of you have seen this system. Now, in terms of trigonometry, what we care is how is this related to how we're going to measure angles. Okay, so an angle is considered to be in a standard form. Okay, so standard form if the first part of the angle starts on the x-axis, exactly in the origin, and this is the first part, and then you measure from here. So this is considered a standard angle and it's on the first quadrant. If you do something like this, you start here, and let's say you go all the way here, then this is also considered a standard angle. So to be a standard angle means you start here, the origin is 0, 0, then you measure this way. So now remember that the whole thing around is 360 degrees. So from here to here is 90, which in the last video, remember, this is clearly a right angle, and you have 4 of them. So the total is 360. So this is 90. From here to here is 180. And then from here to here is 270. And you go all the way around, obviously, is 360. So just to recap on this, angles are measured from here. You have to make sure that this is the starting point, and you measure it from here and go this way. Now, if you go in the opposite direction, it's technically negative angles. So you can also have negative angles. So for example, you have this, and instead of going this way, you go the opposite direction. This part will be considered a negative angle. So if you go this way, it's positive, and you go in the opposite direction, is negative. Okay? Now, one of the first things to notice for angles is that they are not unique. So there's something called coterminal angles. So coterminal just means there are two angles that have different names. You can call it names, but they are exactly the same. So for example, if you have, let's say that this is 30 degrees. So the angle is 30 degrees. Okay? So that's the name of that one. But if you go all the way around, okay, so you go all the way around, after here is 360. So you go 3 more, that will be 390. And essentially you can keep going around as many times as you want. So therefore that means that 30 degrees and 390 are called coterminal angles. Coterminal just means they have the same starting place, which is here, and the same, which is this line, and the same end point. That's it. So that's why they are co-terminal, the end in the same place. Now remember how here I mentioned that you can have angles that are positive or angles that are also negative. So for example, here, you start here and you go all the way around to here. And let's say that this is 310 degrees. Okay. So that's the positive angle. Now from here to here, this is 50 degrees, but since this is going in the opposite direction, this is minus 50. So therefore, that means that 310 and minus 50 degrees are also coterminal angles. Okay, so that's something that's going to be very useful, and it's a little annoying because the names of the angles are not unique. So for example, here, look. Remember we talked about this earlier. From here to here is 270 degrees. But from here to here is minus 90 degrees. So therefore 270 and minus 90 is the exact same angle. That's what it means. Now, something that is going to be more useful later, that we're going to use many times, is called a reference angle, and we're going to talk about this later. So the reference angle is always measured with the x-axis, okay? And the reference angle is similar to coterminal, but it's not quite the same thing. So for example, see, you go from here to here, this is the positive angle, and let's say this is 150 degrees from here to here. So that's 150. So whatever this angle is, which it has to be formed with the x-axis, this is going to be called the reference angle, and reference angles are going to be very important. So here, the reference angle is at 30 degrees. Usually the notation is this. You call theta the angle, and you're going to put theta with a hat on top, and that's going to be the reference angle. And the point of the reference angle is that the values for this and this are almost identical. Actually, they are identical. The only difference will be the signs that you have to watch out for. So let me do one more. Let's say that you go here, and you go from here all the way to here. So this is, let's say, 240 degrees. So that's the angle. And notice that this distance from here to here is 60 degrees. Because from here to here, remember, is 180. Okay, so from here to here, this is 180. So 240 minus 180 gives you 60. So 60 is the reference angle. So theta will be 240, and the reference angle is going to be 60 degrees. And reference angle are going to be very important, okay? Like you'll see in a little bit. All right, so now let's go to the next section, which is trigonometric functions. This is going to be the basis to everything we're going to do. In the last section, we already talked about the coordinate system. So remember, you have 4 quadrants. This is the first one, second one, third, and fourth. Okay. So now we're going to define the trigonometric functions that we're going to use literally hundreds in thousands of times. So let's say you have a right triangle. So this is necessary that it's a right triangle. Okay. And remember, the opposite side, the biggest side is also going to be the hypotenuse. So this is C. And this is the angle theta. You can put the angle in here too. So you'll see that it does matter whether the theta is here or here. Okay? So then let's say this is A and this is B. Okay. So this corresponds to this one, this to this, and this to this. Okay. So now this is the if you look to the angle theta, the A is considered the opposite. So this is the opposite side, and B is called the adjacent side. Okay? So now the next part, this is just the definition. This is how the functions are defined. And you just have to memorize this. So sine of theta is defined to be the opposite, and this is how you should memorize this, the opposite over the hypotenuse. So in this case, it should be A over C. Okay? Then cosine is defined as the adjacent, which is B, over the hypotenuse. So it should be B over C. And then tangent is the opposite over the adjacent. So it should be A over B. Now, each function, each of these three functions has a reciprocal, okay? And reciprocal, remember, is the opposite in the fraction. So the reciprocal of sine is called cosecant, and cosecant is C over A. So notice how you just flip these two. Okay? Cosine also has a reciprocal, which is called secant, and this will be C over B. And then tangent has a reciprocal called cotangent, and this will be B over A. So these are the 6 trigonometric functions. So if you look closely to this, as long as you memorize this one, you should be able to figure out this one's pretty easily, okay? But you do need to memorize this. You should not memorize this as A over C. You should memorize this as the opposite over the hypotenuse and so forth. Otherwise, you may have some issues. Now, usually, they give you all the sides, and if you don't have all the sides, you need to use the Pythagorean theorem to find the other one, which we talked about the Pythagorean theorem before. Okay? So now, remember I also talked about reference angles in the previous part, or like 10 minutes ago. So we're going to use that again in a little bit. Okay? But before I do that, let's start with a simple problem here. Let's say that this one is 12, and this is 5, and this is 13, okay? You can check using the Pythagorean theorem that that's the case. So if that's the information you have, what will be then sine of theta, okay? And sine is the opposite, so the opposite is 5. The hypotenuse is 13, and that's it. So it's as basic as that. So 5 opposite hypotenuse. So which means right away that you know what cosecant is. So cosecant will be just 13 over 5, which is the reciprocal. Okay? Then if you have cosine, cosine is the adjacent over the hypotenuse. So it will be 12 over 13, which means that secant theta would be 13 over 12. Okay? All right, so then let's say you want to find tangent theta. Remember, tangent is the opposite over the adjacent. So it should be just 5 over 12, which means that cotangent is 12 over 5. So as you can see, this is pretty simple, okay? Now, the next part you need to remember for the rest is the following, okay? So remember, this is quadrant 1, 2, 3, and 4. What we care is more basic than that. In the first quadrant, all 6 identities are positive, okay? And this is where the reference angle is going to be important. If you are in the second quadrant, only sine is positive, but if sine is positive, that means cosecant is positive. In the third quadrant is tangent, and in the fourth one is cosine. The easiest way to remember this is the following one. You say all students take calculus. Okay? And that's the easiest way to remember this. Now, let's try one more example. let's say you have another triangle. Let's say that the triangle is somewhere here. Okay, so let's say you have a triangle that is here. Let me move this away. So let's say the T is there. So let's say that this one is this point right here is from here to here. Let's say is a 3, and this one is 4. So you can use the Pythagorean theorem and check that this is 5. Okay. So now let's say this is the new theta. So you want to find the 6 trigonometric identities for this one. So first notice you want sine. Sine will be the opposite. So the opposite is this, which is 4. So, okay, maybe it makes more sense if I put the 4 here. So the 4 is here. So the sine is the opposite, which is 4. The hypotenuse is 5, which, remember, automatically this tells you that cosecant theta is 5 over 4. Okay. Now, if you look to then cosine, it will be the adjacent, which is 3, and the hypotenuse is 5. And then tangent, which will be the opposite is 4, and the adjacent is 3, so it should be 4 over 3. Now, this is where this part is important. Look. Here, all of them are positive. This one only sine, and therefore cosecant are positive. Here only tangent is positive. So therefore, if you follow that, once you get the answer, all you have to do is check. In this place, the only ones that is positive is this one. That means this has to be negative and this has to be negative. So all you have to do is put a minus sign in there, and that's it. So from here, remember this was secant of theta should be now minus 5 over 3. And since this is positive, cotangent of theta will be 3 over 4. And that's it. Okay. All right, so now let's do a slide version of this. Let's say that the question asks you find all 6 trig identities, and it tells you the angle stops at the point minus 2, 4, something like this. So minus 2, 4 or somewhere here. Okay? So therefore, this is the angle. So it goes through here. But the triangle you want is this one. So technically, all you care is this, which is the reference angle. Okay. So this is the reference angle. So that's the one you're gonna focus on. Okay. So now notice here the distance for this triangle. This is clearly 2, and this is 4. So you don't know what this is, so you have to use the Pythagorean theorem for that. So here you have 2 squared plus 4 squared should be 6 squared. Then you have 4 plus a equals to c squared, which implies 12 equals to c squared. And then you take the square root on both sides. That means c is the square root of 12. But remember, this is 4 times 3. So this is 2 radical 3. Okay, so therefore this one will be 2 radical 3. And now you have all sides. So therefore, in this case, this becomes theta is the reference angle, but that's the one you're going to use. All right, so therefore, what will be sine of theta? Well, the opposite is this, and the adjacent is this. So this should be 4 over 2 radical 3. If you simplify, this is 2 over radical 3. All right, and therefore from here, you should know that therefore cosecant theta is radical 3 over 2. Okay? Then cosine of theta, or cosine is the adjacent, which is 2 over the hypotenuse. So this should be now 2 over 2 radical 3, which simplifies to 1 over radical 3, and this means that secant therefore is radical 3 over 1. And then finally you have tangent theta. Remember, tangent is the opposite over the adjacent. So in this case, it will be 4 over 2, which is just 2. And therefore, cotangent of theta should be 2 over 4, or 1/2. Okay? Now, you need to check for the sign. So remember that all students take calculus, right? So since this is in the second quadrant, the only ones that are positive are sine and cosecant. So this is okay, this is okay, but this 4 had to be negative. So you just put a minus sign, and that's it. So it's pretty straightforward when you look at it this way. All right, so let's do another very similar, and let's do part of it pretty quickly. Let's say that now the angle ends in the point, 3, and this one is 5. Okay, so this is 3 and this is 5, so it ends here. Okay, so this is the reference angle. So this is the angle this is the quadrant where you're working with. Now, just to be clear, this side is 3 and this side is 5, so you need to figure out this side using the Pythagorean theorem. Okay? So using the Pythagorean theorem, you have 3 squared plus 5 squared should be equals to c squared. So therefore we have 9 plus 16, plus 25 equals to c squared, which means 35 equals to c squared, which means c is equals to the square root of 34, which you cannot simplify anymore, so it is what it is. So this is theta. So now let's just do a calculus then here. So therefore sine will be the opposite over the hypotenuse. So the opposite is 5 and the hypotenuse is radical 34. That's it. Cosine will be 3 over radical 34. Why? Because this is the adjacent and this is the hypotenuse, which is this. And obviously tangent is equals to just 5 over 3. Now, since you are in the 4 quadrant, the only ones that are positive are cosine and secant. So that means this has to be negative and this one has to be negative. So let me see. So this should be right this way. So you have sine theta should be negative. And obviously, if you know sine, you know cosecant, and you know cosine, you know secant, and so forth. All right, so finally, recall the special triangles. Remember we had 2 special triangles, the 45, 45, and the other one was, this is 30, remember this is 1, this is 60, this is radical 3, and this is 2. So these are the 2 special triangles that I told you we will use many times. Okay, so this is 45 and 45. Okay, all right, so from here we're going to use this as reference angles to solve the problems. So let me give you a pretty basic example. Look, let's say that I ask you to find all 6 trig functions for, let's say, theta is equals to 150 degrees. Okay, so first thing, draw a graph Remember, you had to start the angle in standard form. From here to here is 150 degrees. And then this will be the reference angle where you will make the triangle. So this is the reference angle, which is 30 degrees, because that's how much you need to get to 180. Okay? Okay. So therefore, the reference angle is 30 degrees. So what does that mean? The sine of 150 is going to be the exact same thing as sine of 30 degrees. Remember, sine of 30, this is the opposite, and this is the hypotenuse. So this should be 1/2, which means cosecant is going to be 2/1. Then cosine of 150 is the same thing as cosine of 30 degrees. So cosine of 30, it will be radical 3/2. So it will be radical 3/2, which means secant of theta will be now 2/radical 3. And then finally, tangent of 150 will be 1/radical 3, which is exactly this over this. And then therefore cotangent of 150, it will be radical 3/1. Okay. Now, which quadrant is the reference angle at? So you are in 150 degrees. So this is the second quadrant. So remember, in the second quadrant, only sine and cosine are positive. You should always just do this. All students take calculus. So here is only sine, and therefore cosecant are positive. So therefore the rest will be negative. So this is negative, this is negative, this is negative, and this is negative. Notice that the answers to this are exactly the same answers as the special triangle. So therefore, all you need to know is figure out what the reference angle is, and you already have the answers here. If you don't have a special triangle, then you have to use the Pythagorean theorem to figure out the previous, to figure out all the values, which is what we did in the last two examples. But if you have any problem where the reference angle is these special triangles, which remember there's only two special triangles, 45, 45, and 30 or 60, all the answers are already here. Okay, let me do another two examples so you can see what I mean. Let's say now it's the same question, but let's say theta is 120 or 240 degrees. Let's go with 240. Okay? So 240, you go from here to here, this is 180, you need 60 more, so therefore the reference angle is 60 degrees. So therefore we're going to focus now on 60 degrees. Okay, and then we'll worry about the sine last. So this is 240 degrees and this is 60. Okay, all right, so sine of 240 is going to be the sine of 60 degrees. So sine is the opposite over the hypotenuse. So this should be now radical 3/2. Now cosine of 240 degrees is the adjacent. The adjacent to 60 is 1. And therefore the hypotenuse is 2. So this is 1/2. And then finally tangent of 240, it will be the opposite over the hypotenuse. So it will be radical 3/2. Then, since this is in the third quadrant, on the third quadrant only tangent is positive, which means this one is positive, and therefore this is negative, and this is negative. Now, remember that you already know sine of 240, you also know cosecant, right? So cosecant of 240 is just the reciprocal, so it should be minus 2/radical 3, and so 4 here. Secant of 240 degrees, obviously going to be minus 2 over 1, and so forth. All right, so lastly, let's just do one with 45 degrees. So let's say that the angle is 315 degrees. So notice that 315, if you go from here to here, is 270, so 315 is somewhere here. The reference angle, whatever you need for 360, it just happens to be 45. So therefore you had to worry about the 45 degrees, which is this one right here. So therefore from here, sine of 315, it will be the same thing as sine of 45. And sine of 45, the opposite is 1, the hypotenuse is radical 2. So this is 1 over radical 2, which sometimes it simplifies to radical 2 over 2. And then cosine of 315 is the same, you should check, which is radical 2 over 2. And then finally, tangent of 315 is going to be the opposite over the adjacent, which both of them are 1. So the answer is 1 over 1, which is just 1. Now, since you are in the fourth quadrant, remember the fourth quadrant, only cosine is positive, which means this is negative and this is negative. And also, remember, you already know sine of 315 is minus 1 over radical 2. That means that cosecant of 315 will be minus radical 2 over 1. Same thing for this one, but this is going to be positive, so that means secant of 315 will be radical 2 over 1. And finally, cotangent of 315 will be minus 1. And that's it.